Hey class, welcome back to my ongoing seminar series. Today we'll be exploring some of the ocean's strangest inhabitants. Most people imagine sharks, giant squid, and terrifying monsters lurking in the abyss. They are wrong. Let's begin. We'll start with the sea pig.
Ew.
A fair assessment. Sea pigs belong to a group of animals called sea cucumbers. Unlike their more dignified relatives, however, evolution appears to have abandoned them halfway through construction. These plump little creatures live between 1,800 and 22,000 feet below the surface, wandering the abyssal plain on inflatable hydraulic legs.
Those are legs?
Technically, tube feet. They inflate and deflate them like tiny biological airbags, allowing the animal to walk across the soft mud without sinking. Ingenious and repulsive. Sea pigs spend their entire lives shuffling slowly across the ocean floor, using 10 retractable feeding tentacles to sift through the mud in search of bacteria, decaying organic matter, and whatever unfortunate creature recently became someone else's lunch.
So they eat dirt?
They eat expensive dirt. Deep sea sediment contains nutrients that have spent months, sometimes years, slowly drifting down from the surface. To a sea pig, this is considered fine dining. Despite living in complete darkness, freezing temperatures, and crushing pressure, sea pigs are astonishingly successful. In some regions, sea pigs account for more than 95% of all animal biomass on the sea floor.
So they're winning?
Decisively. Hundreds of them have been observed marching together in the same direction, using ocean currents to detect the scent of distant food. Imagine an enormous herd of blind sausages slowly migrating toward a dead whale. If they ever develop ambition, we'll only have several weeks to prepare for the invasion. Researchers have also discovered juvenile king crabs hiding beneath sea pigs, using them as tiny mobile shelters while they grow. The sea pig does not appear to mind, or perhaps it simply lacks the emotional capacity to object. Finally, should you ever feel tempted to bring one home, don't. Sea pigs are adapted to immense pressure. Their bodies are mostly water and extraordinarily delicate. When brought to the surface, they usually collapse into something best described as biological soup.
That's, sad.
Yes, extremely. The consistency has been described as disappointing. Fortunately, no one can hear them screaming.
Wait, what?
And now, thanks to my recently acquired beaming technology, we can observe what happens when a sea pig is brought to the surface.
Wait, what are you doing?
The sea pig is currently being protected from our atmosphere and pressure by this force field. If we drop the field, we can observe what happens when it is exposed to surface conditions. Fascinating.
You just killed it.
For science, I demonstrated a physiological phenomenon.
That's not any better.
Delicious with croutons. Let's continue. Next we have the Dumbo octopus, one of the few deep-sea creatures not specifically designed to haunt your nightmares. Named after Disney's flying elephant, the Dumbo octopus gets its nickname from the pair of eel-like fins on either side of its head. Rather than relying solely on jet propulsion like most octopuses, it gently flaps these fins to glide gracefully through the water.
It's actually kind of adorable.
It lives nearly 4,000 meters beneath the ocean's surface, making it the deepest living group of octopuses known to science. At those depths, sunlight has long since disappeared, temperatures hover just above freezing, and the pressure is hundreds of times greater than at sea level. Human blood uses iron to carry oxygen around. In comparison, the Dumbo octopus relies on a copper-based protein called hemocyanin, giving its blood a distinctive blue color and allowing it to transport oxygen far more efficiently through the freezing oxygen-poor depths. Another unusual feature is what it lacks. Octopuses are famous for having ink sacs. However, the Dumbo octopus has no ink sac. In the deep sea, there are relatively few predators, so evolution decided carrying an emergency smoke bomb was no longer worth the effort. Instead, it searches the seafloor for worms, tiny crustaceans, and snails, using sensitive cirri around its suckers to detect prey before swallowing it whole. The females of this species carry eggs at different stages of development. Whenever they find a suitable spot, they gently place an egg on the sea floor, leaving it to become someone else's problem.
So she just lays the egg and leaves?
Precisely.
Isn't that a little cold?
They're octopuses, Kirsch.
That seems rather irresponsible.
On the contrary, every Dumbo octopus alive today is descended from parents who made precisely that decision. Would you like to see what happens to a Dumbo octopus when one is brought to the surface?
No.
Or perhaps we could observe a baby giraffe under deep sea pressure conditions.
No, please, no.
Very well. Most creatures avoid being eaten by running away, hiding, or evolving some form of defense. The bloody belly comb jelly solved the problem in a rather different way. It evolved a stealth digestive system.
That's a sentence I wasn't expecting.
Living hundreds of meters beneath the ocean's surface, this remarkable creature inhabits a world where even the smallest flash of light can mean death. Its body is almost entirely transparent, while rows of tiny beating cilia scatter light into shimmering rainbows as it drifts through the water. Unfortunately, shimmering rainbows are not an ideal camouflage strategy. Evolution therefore gave the comb jelly a rather ingenious solution. Its stomach is a deep blood red, not because it enjoys being dramatic, although I respect the commitment, but because red is effectively invisible in the deep sea. Water absorbs red wavelengths long before sunlight reaches these depths, making its stomach disappear into the darkness.
Wait, then why make the stomach red?
Because dinner glows. Many deep sea animals produce their own bioluminescence. Without camouflage, every meal would illuminate the comb jelly from the inside, like a floating lantern advertising today's menu. Instead, the dark red stomach absorbs the light, allowing predators to swim past without realizing it has recently eaten. Unlike true jellyfish, comb jellies don't possess stinging cells. Instead, they capture prey using thousands of microscopic sticky cells called coloblasts before quietly swallowing them whole.
That's actually brilliant.
It is. Imagine evolving a camouflage system specifically to hide the evidence that you've just eaten someone. The next specimen on today's list is the barreleye fish. At first glance, it appears to have a completely transparent head. For many decades, it was assumed this was an unfortunate manufacturing defect. The barreleye fish lives between 600 and 800 meters beneath the ocean's surface, where the last traces of sunlight barely penetrate the darkness. For a long time, scientists only knew this remarkable fish from damaged specimens, because its delicate fluid-filled head collapsed when brought to the surface. It wasn't until 2004 that researchers finally observed it alive using remotely operated underwater vehicles. Its transparent shield protects a pair of extraordinary tubular eyes, which are the two bright green structures visible inside its head.
Then what are the eyes on the front of its face?
Those are its nostrils. Evolution occasionally enjoys practical jokes. The barreleye spends much of its life hovering perfectly still while its eyes point upwards, scanning for the silhouettes and bioluminescent glow of prey drifting overhead. Once it spots something interesting, its eyes rotate forwards, allowing it to pursue its target with remarkable precision.
Its eyes move inside its head?
Correct. Most animals simply turn their heads. The barreleye considered that inefficient. Its transparent head shield serves another purpose as well. Scientists believe the fish frequently steals food from siphonophores, long colonies of jelly-like animals armed with thousands of stinging tentacles. The barreleye carefully approaches from below, rotates its body into position, and plucks trapped prey from the tentacles, while its protective shield prevents its sensitive eyes from being stung.
So it's stealing someone else's dinner.
Indeed, rather than hunting for food itself, the barreleye simply waits for somebody else to do all the work. An approach I suspect would appeal to a great many people. Next we have the tripod fish. At first glance, it appears to have extremely long legs.
Fish don't have legs.
Correct. They are modified fins, which allow this unusual fish to stand above the seafloor rather than resting directly on the mud. The tripod fish inhabits the abyssal plains nearly 5 kilometers beneath the ocean's surface, where food is scarce, sunlight is non-existent, and wasting energy is generally considered a fatal mistake. Rather than constantly swimming, it remains almost perfectly motionless, facing into the current and waiting for small prey to drift within reach.
It just waits.
Precisely. Facing into the ocean current, it patiently waits for tiny shrimp, crustaceans, and other drifting prey to come to it. Its long pectoral fins are held out like sensitive antennae, detecting the slightest movement before guiding unfortunate prey directly into its mouth. Patience is considerably easier than exercise. Living in perpetual darkness has also made eyesight somewhat redundant. The tripod fish's eyes are greatly reduced, leaving it to rely almost entirely on touch. One final adaptation deserves mention. The abyssal plain is so sparsely populated that encountering another member of your own species can be remarkably uncommon. To solve this inconvenience, the tripod fish is a simultaneous hermaphrodite, possessing both male and female reproductive organs. Some researchers believe it may even be capable of fertilizing its own eggs if another fish cannot be found.
That's either incredibly lonely or incredibly efficient.
Those aren't mutually exclusive. Next we have the pyrosome, also known as the sea pickle. Despite looking like one enormous gelatinous creature, a pyrosome is actually a colony made up of thousands of tiny individual animals called zooids.
So the sea pickle is a group project.
Essentially, although unlike most group projects, every member actually contributes. Each zooid is only a few millimeters long, but thousands of them join together in a hollow tube-like structure connected by a shared gelatinous outer layer. Working together, they pump water through the center of the colony, allowing the entire structure to move through the ocean as though it were a single organism.
So it's thousands of tiny animals pretending to be one giant animal.
Exactly. Evolution has occasionally favored teamwork over individuality. The pyrosome feeds by filtering tiny organisms, such as phytoplankton, from the water around it. At night, the colonies rise closer to the surface to feed, before sinking back into the deeper waters during the day and transporting organic material down to the deep sea. They are also remarkably successful under the right conditions. Large blooms of pyrosomes have been known to clog fishing nets and interfere with scientific equipment, creating the unusual situation where a harmless-looking sea pickle becomes a serious inconvenience. However, their strangest ability is their bioluminescence. Each zooid contains its own light-producing organs, and when one individual detects movement or a disturbance, it can trigger a wave of blue-green flashes that travel along the entire colony.
So it's a glowing underwater tube made of thousands of tiny animals.
Exactly. Thousands of individual animals behaving with such precision. They appear to possess a single mind. Our final specimen today is the deep-sea anglerfish. Living thousands of meters beneath the ocean's surface, where sunlight never reaches, this remarkable predator has solved the problem of finding food in complete darkness.
By becoming everyone else's sleep paralysis demon.
A fortunate side effect. The female anglerfish carries a long modified fin ray extending from the front of her head, ending in a glowing lure. Rather than producing the light herself, she houses colonies of bioluminescent bacteria inside the bulb, creating what is effectively a living fishing rod. Small fish, shrimp, and squid mistake the light for an easy meal. They soon discovered they were the easy meal. The anglerfish saves energy by drifting almost motionless through the water, waiting patiently for prey to approach. When something gets close enough, its enormous jaws snap shut in a fraction of a second.
So it doesn't hunt?
It allows lunch to hunt itself. Food is scarce in the deep sea, so when the opportunity finally arrives, the anglerfish wastes nothing. Its stomach can stretch to swallow prey considerably larger than itself.
That's ambitious.
Hunger often is. Some species possess skin so extraordinarily black that it absorbs almost all incoming light, making the fish nearly invisible until the lure suddenly appears from the darkness.
That's horrifying.
We haven't reached the horrifying part. The males are tiny. They possess no glowing lure and spend their lives searching for a female. When one finally succeeds, he bites her.
That seems rude.
Shortly afterwards, his tissue fuses with hers, their bloodstreams merge. He loses his eyes, his digestive system, and most of his internal organs. Eventually, he becomes little more than a permanently attached reproductive organ, surviving entirely from nutrients supplied by the female. Larger females have occasionally been observed carrying several permanently attached males simultaneously.
Several? Bow chicka wow wow.
Don't be gross, Kirsch. Class dismissed.
Okay, Sylvina, that's a wrap.
Fascinating.